This stream is live. I love seeing that. Here we are, LinkedIn live session, relational AI, all things AI, tariffs, supply chains. Oh my. By the way, Trump cooperated with us this morning. He reached out. We asked him to do a couple more things around the tariff stuff, and he did that at 9:15 this morning. Not to hijack Max's presentation, but there will be some references to that. All that being said, we really appreciate you being here for this. This is going to be awesome. I promised Max that I wouldn't talk too much on the front end in particular, but we want to welcome you. We also want to let you know that we recognize the complexity in the supply chain. And we also recognize the complexity that is increased when you have campaigns, or excuse me, when you have an administration that's moving rather quickly, as I mentioned this morning. And sometimes when we think about that complexity, we think about it, from first principles, and there's a lot of data foundation that if it is modernized, it makes it a little bit easier to navigate through simulations and knowledge graphs and digital twins, which we'll get into. And if it's not modernized, it can be even more challenging than it was before, because things, as they change, it becomes difficult to predict and project where to go. But the good news is I've got the right guy with me here in Max Marzi. Max is a knowledge graph expert and subject matter expert here at RelationalAI. Fantastic, awesome guy who also presents, I think, in an exceptional way, where he takes very complex technical concepts that, can be difficult at times to bring through for those of us that aren't engineers, but he does an exceptional job just delivering it in a way that's universal. He uses pop culture references, and he's helping me understand how important it is that I correct the fact that I haven't seen Star Trek yet, because there's this guy named Lore who apparently is quite cool and is connected to Max's presentation. So Max, without further delay, I hope I didn't steal your thunder at all. I and everybody watching are very excited to hear what you have to say on AI, tariffs, supply chains. Oh my.
All right, let's get started. So before we get into AI and tariffs, we need to start talking about Crocs. And specifically, Donald Trump and Crocs. And even more specifically, we're talking about Crocs paying large amounts of money due to tariffs being imposed upon them because of Donald Trump and his new policies. If you didn't know, Crocs sources about 28% of its products from China. Those little plastic shoes, they come from China, and many other products that they build as well. And it's not just the Crocs, right? There's many companies that are affected by these tariffs that are being announced almost on a weekly basis. Your glasses, your jeans, your t-shirts, just about anything you have in your household usually comes from outside of the U.S. Not to call out any specific companies, but as an example, we have things like Skechers and Yeti and Warby Parker and Nike, the incredibly named UGG company, right? And even things that you thought were super American, like Wrangler jeans and Lee jeans. Well, part of their inventory is made abroad and brought over through Mexico or China or Canada or Cambodia or Thailand or wherever else they may be sourcing the data. Hundreds and hundreds of companies are being affected by these tariffs. And it's creating a bit of a conflict, if you will, in the world. We'll see what he announced today, but first things started off with Mexico and Canada, and China was brought into the picture, and now things are starting to get a little bit messy with this idea of reciprocal tariffs, where the U.S. is going to basically tariff everyone who tariffs it, and we're just going to punch each other in the face until someone gives up, I guess. So these tariffs have the potential kind of to disrupt the supply chains all over the world. If you've been in the supply chain business for a few years, you might remember this picture. This is the Evergreen container ship blocking the Suez Canal and basically disrupting supply chains for a few weeks. Well, these kind of announcements that are occurring are happening every single week. And your supply chains and your software have to deal with it and have to make adjustments and have to change with the times. He announced this morning that he was going to start implementing reciprocal tariffs against literally every other country in the world. So that's going to affect everyone's supply chain, no matter what you end up building. So let's focus in on one particular company, one particular product. And this is going to be a supply chain management system at Yeti Coolers, let's say. If we start from the right-hand side, we have retail stores. So we have people who want to take their drinks to the beach on a hot day in the summer, and they go to the retailer and they demand to buy some Yeti coolers. Well, these Yeti coolers come from a warehouse that has inventory kind of laying around waiting for these retailers to demand it. And this warehouse got their coolers from a different factory that packed all these Yeti coolers in a pallet and shipped them over. And these got there by a factory that made these coolers. And of course, the materials required to make these coolers were sourced by some suppliers. That's where they get their plastic, in this case in China or Vietnam or what have you. And this supply chain also incurs things like machinery, right? You have to mold these Yeti coolers into their shape. And you need people, you need labor to move this plastic around, move these Yeti coolers around, pack them and ship them and sell them and display them in the different stores. And you have to have an intelligent supply chain to make it efficient. You have to know the what, the how, the when, the where, and the why of how things are going to go through your supply chain in order to squeeze out every single piece of profit you can. Now, Yeti keeps track of its supply chain data as tables in relational databases, right? This is how most people see the world, as tables. And they're connecting materials to operations, to inventory, to warehouse capacity, to retail demand, and a lot more in these tables. And these tables are everywhere. And it's probably not just one single source system that controls it all. It's probably a collection of databases, some at the different factories, some of the warehouses, some at the retailers, or anywhere in between. And unfortunately, this is going to mean that our data is going to be messy, it's going to be siloed, and it's going to be all over the place. You might have heard that phrase before. This was a LinkedIn post from Matt Turk, where he says, hey, the problem in 2010 was that our data was messy, siloed, and all over the place. And in 2016, the problem was that our data was messy, siloed, and all over the place. And today, the problem still remains. Whether we're doing analytics, we're doing business intelligence, we're doing machine learning, or now everyone's kind of turning their hat to look at AI work, it's still exactly the same problem. And the way we, quote unquote, solve this problem has been by moving data around. We're going to go from databases to data warehouses to data lakes to data lakehouses to data meshes to whatever, but that never works. All we seem to be doing is just taking data, putting it in some kind of container and moving it around, and it just gets stuck somewhere, just like that ship in the canal. The data is not enough, right? You keep moving data around, but you're not moving what's really important, which is lore. And the trekkies in the room will undoubtedly remember Data's twin brother, Lore, from the few episodes that he appeared in. Now, lore is your business. It's what makes you different from all of your competitors. You know, if you think about, 6 tobacco companies, they all have the same product. They all produce it in the same way. They all manufacture it in the same way. They all package it in the same way. They have to obey the same laws and regulations in every country that they operate in. But what makes them unique is their business rules, their business knowledge, how they think of the world as that particular brand or that particular business. So the data is exactly the same. So moving the data around is not going to make a difference. It's going to be something more than that. So we're going to offer a new solution, which is we're going to solve our problem by building a relational knowledge graph instead. We're going to take our relational data model in tables, and we're going to create this relational knowledge graph that's going to be made up of entities and relationships that are going to be named so that you have some semblance of how things are connected, and pipe it all together into what most people think of as a digital twin. We're going to create a way for you to understand your business digitally, because it's impossible for any one person or any set of analysts to understand your business in the real world. So how does this work? Well, we have to build a knowledge graph, and the knowledge graph is more complicated than just what people think of as a level 1, where you have data, and these are going to be your nodes in your relationships. You have things like the name of someone, the address of a location, the address of a warehouse, maybe a picture if you're storing that kind of data. That's fantastic to at least have that. And even that is a humongous job, cleaning all that data up and forcing it to make sense in one place and getting rid of the null values and the values that are have typos in them, and cleaning all that is a huge undertaking already, but it's not enough. Level 2, we start getting into queries. This is data of data, right? How do we use queries to produce more data from the facts that we already know? How do we go beyond just the little things that we know? So these are things like, well, I can figure out someone's age by looking at today's date minus their date of birth. Say, oh, I know they're 45 or 46, or because of that, they qualify for this, or they qualify for that, or what have you. I can figure out that people usually have a single date of birth, not multiple times, and they only have one age. These kind of rules we can think of as constraints or invariants, and they're used to know things that we already know about the data. Just go one step further than the raw data that has like someone's name or address. And then when things get interesting is level 3. This is when we start feeding into intelligence, and that's the ability to create views that use reasoning, right? The idea is, okay, well, what is your age? How old are you? Well, what if I don't know that? What if it's not in the data? Well, I can look at your friends and say, well, the majority of your friends are between 33 and 35. You're probably 34 years old. I can make a guess that looks and feels realistic based on who you know and who your friends are, even if I don't know something about you. We can tell the same thing about somebody's propensity to smoke or drink, what kind of car they drive, what kind of job they have, well, who are your coworkers? If everyone you are connected to on LinkedIn is in tech, you're probably in tech. If anyone you connect to on LinkedIn, is doing something else, then they're probably doing something else. So your network can tell us information about your data. But it's not just that. Can we ask the knowledge graph to tell us the fastest way to ship something from one place to another below some kind of cost threshold, right? Using solvers. Or can we ask our knowledge graph, what will this person buy next week or next month or next year, right? And do some probabilistic reasoning. Those kind of ideas are what we're going to build on top of your knowledge graph. So go beyond just the data aspect of it. So let's look at some code. No, actually, I'm just kidding. We're not going to do that. We're going to keep it high level. And let's go back to Yeti for a second. You guys remember Yeti is a company that makes these little coolers here. And they want to build this intelligent supply chain knowledge graph. So they're going to load their data from various sources, probably into a data warehouse like Snowflake. And they're going to use these as the source of the data into the knowledge graph. Now, we're going to start from here, but we need to go beyond it. So we're going to add some business logic. We're going to add some rules to say, okay, this table represents this kind of entity, and this entity has these properties that I care about, and then has these relationships that I care about. We're going to start building our data model as a graph. This is going to allow us to run queries across the different nodes, across the different relationships, from one end of the business, from everything from like a bill of materials of how a product is made, all the way through manufacturing, all the way at the end through the legal ramifications of what affects a product along the way, and also your consumer and what they're likely to purchase from you. The whole business end to end can all be connected together. And we're going to take all that logic that is hidden away in thousands and thousands of lines of SQL, Java, Python, and who knows what else, in all the dozens of applications that you've built over the last few decades that use all this data that you've collected. We're going to move them all into this knowledge graph, or as much as we can really into the knowledge graph. You're going to have a lot of duplicates. You're going to have a lot of logic that actually argues with itself, or that doesn't make any sense, or that your company bought a different company and they do things slightly different. So now you have to reconcile all that logic and make sure that you have one cohesive view of the world. And once you build that, disaster strikes and you have a change in your knowledge graph. Oh, great. Now we have this tariff that we have to deal with, and how is that going to affect things, right? So we have a bunch of sites that manufacture some of our products. They happen to be in China or wherever else, and now they have to deal with a new tax. So we can start by saying, all right, let's use graph analytics and say, find everything that happens to come from this site and use an algorithm called reachable to see how it connects to the rest of my graph, the entire graph. I don't care how deep it is, whether it's 20 tables away and locked away or 100 tables away, somewhere deep and dark hidden away. It's going to find it and say, yes, because of this change, now I have to make an adjustment to how I treat this information on this other side of the world. So you can use reachable to find all the nodes in our supply chain that are affected by a legal change like a tariff or a new tax or what have you. And obviously, that's just one of many graph algorithms out there. You can use graph algorithms to do things like clustering, to cluster your products or your customers, to see similarity between customers or products, to look at a prediction of whether a customer is likely to purchase a product, using things like triangle count and what have you. There's many kind of graph analytics you can use in this knowledge graph. Now, Yeti was smart, or they got a tip a while back ago, and they realized that even though they make a lot of their core products in China, it also has manufacturing facilities in the Philippines, Vietnam, and Taiwan, and Poland, Mexico, and so on. And it realized this, and they also know that if the secondary source, in other words, the second country where you also produce an item, all of a sudden their cost starts to go a little bit higher than their primary source, that's okay. But if the primary source becomes more expensive because of a tariff, then you have to dial that down and dial up your secondary source to rebalance to be the most efficient. So this rebalancing that needs to happen is the problem that they're facing, right? And every company that is going to be affected by these tariffs is facing. They're going to have to change how they run their business in order to make it work. Now, the last thing you want to do is send an angry Yeti rampaging through warehouses and manufacturing facilities and just ripping stuff apart and trying to figure it out. You want to have a calm Yeti instead, someone who understands what the rules mean, what the tariffs mean for them, and can figure out which levers to adjust to get the best results, right? Which lines do we want to stop? Which lines do we want to increase? Where do we want to end the third shift? Where do we want to create a new third shift? Where do we want to clear out the warehouse? Where do we want to stock up? All those kind of decisions are called prescriptive analytics. Here is where you define some variables, like I have this inventory and I have this capacity to build more at this warehouse, for example. Then you have some constraints. I have this demand that is coming in from these different locations and have a period of time that I'm concerned about. Let's say it's going to be next summer that I care about. And then we have an objective function. I want to find the best way to meet this demand, in this case, and trigger the least amount of operations and minimize the costs required in order to do this. And then I want this thing to go ahead and solve this for me. So here we're using mathematical optimization. We're using a solver to figure this out for us using the same knowledge graph that we used earlier to find products that were reachable from any country or any location. It's the same exact knowledge graph. We're doing a completely different set of work. So we run our model and it tells us that these are the two things we can do to meet that demand in the least amount of cost. So let's go back to Crocs. Now they are trying to figure out how many shoes to manufacture in order to meet the demand this summer as well. And the head at Crocs says, listen, data scientist that I pay way too much money for, I need you to generate some features for me and build a machine learning model and figure this out. But the data scientists are like, oh man, that's a lot of work. That's going to take forever. We're not going to meet summer deadline if we do this now. So instead, we're going to do something a little smarter. We are going to use the shape of our knowledge graph to build a graph neural network and let the graph figure out what features are important, what features are required in order to make this work. And we're not going to do all the dirty work. We're just going to let the shape of the graph tell us. So they built this thing, and it's called predictive analytics. So we're going to use the graph neural network to take the data that currently lives in our relational tables. We've already ingested it into a graph. And from this graph, we're going to build the graph neural net. It's going to generate some embeddings that capture the shape of these nodes, the shape of the neighborhood of these nodes, the shapes of the random walks of these nodes. And that's going to allow us to do things like classification, link prediction, and regression. So we'll be able to ask it, well, how much cement will we have next summer? And it will be able to perform some calculation and hopefully tell us an answer that's close to what the reality will be. At this point, some of you are thinking, okay, hold on, this is a bit over my head. What's the difference between predictive analytics and prescriptive analytics? The way to think about it is this. In machine learning, you are going to predict what the future may be. And in mathematical optimization, you're not worried about the future, you're worried about today. So you're trying to decide which levers you can pull in order to get the best out of your situation today, not so much about what's going to happen in the future. So that's the way I like to think about it and how you differentiate between the two. And that's all fine. You know, analytics is great and all that. But sometimes your croc gets lonely and they just want to talk to someone about all this stuff. They just want to have a little sidekick that they can ask questions about the business and ask questions about what's happening in the world and get some answers from them. So what they want to do is talk to your graph. They want to be able to ask questions in natural language and say, hey, listen, I want to figure out how much plastic is required to make 1,000 of these classic cross-light clogs. And they ask the question in English, and we get back a query that they can run against this knowledge graph that will give them the answer. This feature is currently in preview, but this is kind of what it looks like. The ability to talk to your graph about your data and get an answer that is correct and not hallucinating and not doing anything silly like that. So if any of these use cases resonated with you and you want to find out more about knowledge graphs and relational AI, please get in touch. And I'll stop here and thank you. We'll go to questions.
All right. That is awesome, Max. And I can't believe you flowed through that as quickly, but as clearly as you just did. I have 15 questions, but I'm not going to ask all of them and bore everyone. I'm going to ask you one question though, because you said something there that I actually haven't heard you say it the way you just did. That was super interesting. Not that the way you said it in the past hasn't been interesting, but tell me a little bit more, double click for the audience here. When you say using the shape of the graph to help a user better understand a potential, let's say a simulation or an outcome or potential outcomes, can you explain a little bit more about how you could use the shape of a graph in response to, rapidly changing environments with, tariff stuff, that could benefit the way an individual might think about their planning and their preparation and scenarios and simulations about what could happen. And if and when this happens, then that. Like, I love the way you broke the Yeti thing down with China versus Vietnam and several other places.
Let's start with the shape of the graph. So in traditional machine learning, what you build is features. And sometimes you'll build dozens or hundreds of features. And these features are questions, basically. Say, how many friends do you have? Or how many orders did you get last week? Or how many facilities can produce this product next week? Those are the kind of questions you're asking. But they're really just SQL queries, or they're database queries that connect one item or one set of items to many others, right? 1, 2, 3, 4, 5 hops away. So these features, they have to be invented, or they have to be at least thought of by a data scientist. And they may have an idea which features could help answer some questions. So they'll come up with hundreds of these features. They'll build a machine learning model, and then the model will tell them, you know what, out of these 150 things you gave me, only 12 were actually useful. The rest are completely not going to make any change to anything I do. The problem is you don't know what those 12 are until you build the 150 first. And then sometimes your customers or the world has a large behavioral change, like a tariff, or you have fraudsters who discover a new way to attack your system. So now you have to have new features in order to deal with the new change in the world or deal with these smarter fraudsters. And now you go back to your data scientists, come up with another 100 features and see which one of these are useful. And that's very painful and very expensive work. So with graph neural networks, what you're able to do is, instead of doing any of that, you just say, I have my graph. It's connected this way. It knows what tables are related to what tables. And it's just going to randomly walk through the neighborhood that it has. And it's going to use that random walk, which is just basically the shape of the graph, to create these embeddings. And that's what we're going to use for a machine learning model instead of creating embeddings from all these features that we built. What's nice about it is it requires a lot less work for a data scientist to build. And if things change, like laws change, tariffs, or if you have fraudsters who get smarter, well, they change the shape of the data as well, and it will be automatically picked up the next time you run your model against it. So you don't have to come up with these new features. You can just say, oh, the shape has changed, therefore we're going to get a new random walk, therefore we're going to get a new embedding, and we'll kind of just keep it up to date. And that's how that works.
That's fascinating. And I'm gonna double click on one more thing just in case the audience did pick up on it. And then you correct me if I'm wrong, as always. I think that essentially what we're talking about here is, let's just say a large company has hundreds of thousands of lines of code associated with the data sets that we're talking about that need to be interpreted to, make better decisions and so on and so forth as the world changes. And a knowledge graph essentially extracts or elevates the logic associated and embedded within all of that kind of, there's a lot of mud in there. I think you mentioned accidental complexity and so on and so forth. Understandable, but it's like mud. And so you elevate it so that then you can interface with it and you can make decisions faster by identifying and understanding the stuff that's the most important and not necessarily having to navigate through all the mud. Is that fair? Is that, or am I off on that?
No, that's fair. Teaching your knowledge graph about your business, it's the critical part that a lot of people miss.
Yeah.
Right. If you just teach the data and you try to talk to it from a machine learning model or a graph neural net or a large language model, it's just going to go against tables that it doesn't understand. It's just, a table in a relational database is just ones and zeros. It's a bunch of numbers. They all kind of point to each other by a number, and you hope for the best. But when it's in a knowledge graph, you have real relationships. Right? The relationships have meanings, and they're there for a particular reason. Maybe they expire, maybe they last, maybe they have weights attached to them as well. So your answer is more likely to be correct. Also, we're not just querying data alone. You're able to take all your business rules and put them into the graph as views. So now you're not querying a table, you're querying a view inside of your graph to get better answers, get more concrete answers out of what you're doing. So that's the idea there. But yeah, it's bringing all the complexity, which may be in hundreds of different applications. And if you have a large conglomerate that owns lots of businesses, you definitely have duplicates of application logic everywhere that you need to kind of come into one spot. And the knowledge graph is the perfect place to put all that.
All right, we're gonna go one step further. Here comes, another one of these, Captain Obvious Alec questions. But you mentioned Snowflake a couple of times. I know, as a native application, I think I know exactly what that means. But for those that don't, is it safe to say that everything you just described, more or less, can happen within the Snowflake environment? Because as a native application, this is not a point solution. This is not, oh, you got to do something over here and something over there. This is end-to-end AI workloads. Everything happens in the Snowflake environment, as a result of relational AI being a native application. Is that right? And do you want to maybe dig into that a little bit?
Sure. So the idea is we're going to go where the wild things are, right? And most people who have large amounts of data, they're going to put it in data warehouses, and Snowflake being a perfect example of that. So we are going to live within the same environment. We're going to keep our computation inside of the environment, so the data never leaves, never goes to our system, never goes to anywhere you don't want it to go. And we're going to work seamlessly with your Snowflake tables. You can think of relational AI as a giant view on top of your existing data. You tell us which parts of your data you want to project into a graph, and we're going to keep that data up to date. So as your data changes in Snowflake, it'll change in our system as well. We'll keep it all in sync using streams and change data capture. So you set it up once and you never have to think about it again. A lot of pain comes from having to build like complex ETLs and all that. All that is gone because we are also relational, and we just point to your relational tables exactly where they are. You don't have to format your tables in weird ways or do anything funky. You just put your data in Snowflake like you normally do, and we'll take it from there.
All right. Last question, got about 90 seconds left. You tell me on this one. It seems very clear to me that this is a pretty obvious answer, right? Execution velocity, decision-making velocity, being able to become more nimble. There's a lot of benefits here. What would you say are like a couple of the challenges that companies, might think they will face in moving in this direction that maybe that aren't as difficult as they might perceive? Because there's got to be some obstacles that are in the way of more companies doing this because they frankly, they just should. So like any quick and dirty, like, hey, here are 2 or 3 things that you don't need to worry about. It's not as hard or as complicated as you might think, and let's go.
No, the technology part is easier than you think. The harder part is the political part of getting your finance department, your marketing department, your HR department, your warehousing, your data scientists to all decide to want to switch to a new system together or to come to a new system together and to build relationships between the data that lives in 20 different places cohesively is the biggest challenge. So what we always propose is don't try to boil the ocean and do it all at once. Pick one project, pick one problem that really hurts, and let's go help that one fix, get one solution done, and you'll get the political win from that, and hopefully that'll carry over to your conversations with other leaders in different divisions, different departments in the business, and they'll come on board and say, you know what, I want to be a part of this and get on the train and move forward to the next generation of databases and knowledge graphs.
Nailed it. I love it. So we're going to wrap on that. If anyone has any additional questions, you know where to reach us. And if you don't, you know where to find us on LinkedIn for sure. So reach out to us there. There will be additional content coming out, supporting this, as well as we will package this back up and play it back. So you'll have bite-sized pieces. But Max, as always, thank you so much for the way that you do what you do. I think it's extremely insightful, easy to understand, and I love the pop culture references. And me and Laura are going to be hanging out watching a movie this weekend. I think you might know what it is.
All right. Thank you. Take care.
See ya.